Assalamu alaikum warahmatullah, respected faculty members. Today in my demo presentation, I would like to discuss with regards to the topic of introducing the enhancement type MOSFET to you all. So basically, MOSFETs are divided into, categorized into two parts generally. One is the depletion type MOSFET, another is the enhancement type MOSFETs. So in this presentation, we will focus on the enhancement type MOSFETs, which are further classified into N-channel enhancement type MOSFETs and P-channel enhancement type MOSFETs. So here, I will just talk a little bit about the construction of the enhancement type MOSFETs. So initially what we have is that the main difference between the depletion type MOSFET and the enhancement type MOSFET is that the depletion type MOSFET has a channel right from the beginning, but the enhancement type MOSFETs, they don't have any channel that will actually carry the charge carriers from the source terminal to the drain terminal. So I will actually talk about this in detail. So initially, what we have to do is that for the construction of the N-channel enhancement type MOSFET is that we need a base silicon, and that base silicon has to be doped using trivalent impurities so that we get a p-type substrate. So for the N-channel enhancement type, we have a p-type substrate, and then we need two wells, N wells, as given over here, obviously with a depletion layer, with a depletion layer. And with the two wells, we have two terminals connected via a metal contact. So one is the source terminal and another is the drain terminal. The source terminal is known as the source terminal because it is the point where the electrons or the charge carriers from which it actually enters the channel, and the drain terminal is the point where the charge carrier exits from the channel and gets out of the drain terminal. So that's the reason it's known as the source and the drain terminal. And then in the construction, we have the gate terminal. So the gate terminal is just in between the well, as we can see, which is also connected using a metal contact. And we have another, the fourth terminal here, which is also known as the substrate terminal or the base terminal, or the base terminal. So it's this MOSFET is mainly known as the enhancement type MOSFET. So why enhancement of what? So enhancement of the channel, which doesn't exist in the beginning. So here, how is the channel created? And the channel is for what? The channel is mainly to carry the charge carriers, right? So here, how is the channel created? So we can also see that in between the metal contact here and the wafer, there is a thin layer of silicon oxide, which is a dielectric, right? So this actually gives an impression of a capacitor, right? We can compare this configuration somewhat to the capacitor, because even a capacitor has a metal plate. A capacitor has a metal plate, and between the metal plate, the capacitor also has a dielectric layer, right? And if we can provide a potential on the terminal G with respect to the terminal SS, right? There is a potential difference created, and due to that, we can see that there is an accumulation of positive charges on this plate and negative charges accumulated on this side of the plate. So if that really happens, then let's see what are the consequences of that. So obviously there will also be a metal contact here, right? And here will be the accumulation of negative charges. And what are the consequences of this? The consequence is that here we have some of the electrons with the holes. Basically, these are the atoms or trivalent atoms, which are or the impurities that are doped in it. And due to the electric field, the holes are going to get drifted at this side. So if the holes are actually drifted at this side, towards this side, we see the holes actually become absent from here, and this becomes bound charged. This atom becomes an ion, and they try to form a they actually form a bound charge layer, and this layer is actually a depletion layer, right? So now we see that there is a channel that is formed, a channel that is formed. And because of this channel, now we can see that the charge carriers can actually move from the source terminal to the drain terminal. So what does that mean? It means that if VGS, so why am I saying VGS? VGS means the potential difference between the terminal G and SS. And why is it known as S and not SS? Because normally we have three terminals in a MOSFET, and these two terminals are actually shorted. These two terminals are actually shorted. So this terminal can also be called as the source terminal right now, because since it's shorted. So VGS actually has to be greater than a minimum voltage. Obviously, it has to be greater than zero to actually form any sort of channel. But just any layer of any thickness of channel will not might not be sufficient enough to easily allow charge to actually pass through. So there is a minimum voltage that has to be surpassed by VGS in order for the easy movement of charge. So that minimum voltage is known as the threshold voltage. So VGS has to be greater than VT, the threshold voltage, in order for the easy passage of charge from the source terminal to the drain terminal. So this is basically means that if we increase the VGS, keep increasing the VGS, then the thickness of the channel will keep increasing, and the enhancement channel, the channel will be more enhanced, and the charge carriers will be easily flowing through the channel from the source terminal to the drain terminal. So this was the very basics of the enhancement type MOSFET. So thank you so much for watching the video.